Hi Reddit, my boyfriend and I have been dating for a year and it has been great. Except for one thing. Dota. The other day, on a Saturday, I was over and he was playing a game. I thought it would just be one, but instead he proceeded to play for 3 hours as I just sat there. What can I do? So this, as you can see, it is a post from a subreddit called Relationships of someone seeking relationship advice. Now, I would claim that this is clearly fake because no one plays Dota for just 3 hours. Crazy. But let's assume that this is a thing that really happened. And well, it doesn't matter. The article here is written, and the task is to summarize this post in as few tokens as you can, but sort of giving much of the information that is in the post itself. So the task here is called summarization. And humans can do this quite well. So here you see a human written reference baseline. My boyfriend games whenever he can. How can I get him to stop gaming so much and focus more on school and our relationship? Okay, so that's a pretty good summary of what goes on in this model. The easiest baselines for this task in machine learning are what's called extractive baselines. So in extractive summarization, what you do is you try to find subspans. So let's say like this span followed by this span and so on, that together represent the article. So you strictly select subspans or even entire phrases from the text that you're looking at. So a lot of these baselines are extractive and they perform already fairly okay. For example, this one right here, help my boyfriend is neglecting his studies and our relationship because of a video game. I think that's just extracting from the title. Okay, that's title policy. There are other models, for example, here this lead to, hi Reddit, my boyfriend and I have been dating for a year and it has been great. I mean, that accurately represents, maybe not, maybe that's not. So you can already see that it's quite hard because not only does a model have to understand what information is in a text and what are the important things, but also clearly it needs to understand something about the intent of the post, right? If you want to compress, you have to compress the meaning, and the meaning, because we are humans, we understand that this person here is distressed, seeking advice, right? It's like, what should I do? And we understand that the source of the frustration is the fact that the boyfriend here plays a lot of this video game. It's not really important, how much they played or even that they've been dating for a year or so on. The problem here communicated is the playing video games. So you see that the researchers here have come up with a bunch of models, and their best model that we're going to look at here is called this human feedback model with 6.7 billion parameters. It's a GPT style model, and we'll get to all of this in 1 second. I'll just want to kind of show you the end result that can output the following. My boyfriend is neglecting his studies and our relationship because of his excessive gaming of a video game. What can I do to get him to stop? All right, so there are a couple of nuances here. Like the what can I do to get him to stop is not really explicitly said in the text. It says it seems like it interfered with our relationship. He's doing his PhD, he's obviously swamped. It goes on the back burner. It makes me rethink our relationship and so on. These things aren't explicitly said, yet the model somehow understands that that's what this person expresses. And if you want to compress this information, then this is a very good thing to, this is a very good summary to output. So we'll go to see how they come to build this model, what it has to do with human feedback, and just in generally how it works, and also where it fails. So this is a pretty big paper. As you can see, it's one of those papers where the appendix needs a table of contents, which is going to come up very shortly. There it was. Lots of references. So it's a paper by OpenAI. Of course, recently OpenAI has made big advancements in language research with GPT-3, and this is from kind of the same style of research. So the paper is called Learning to Summarize from Human Feedback by Nissan Steenon, Long Ouyang, Jeff Wu, Daniel M. Ziegler, Ryan Lowy, Chelsea Voss, Alec Radford, Daria Amondai, and Paul Cristiano, as I said, of OpenAI. So they tackle this task of summarization of these kind of posts or news articles. You can apply this pretty much anywhere, and they incorporate human feedback into it. Now, why do they incorporate human feedback? And that's because summarization isn't a straightforward task, right? So in its basic, if you have a summarization task, you have some sort of a piece of text that contains some information, and from this you want to generate a small piece of text. The small piece of text should be, first, very short, but second, also, it should contain information. It should contain all the information that was contained in the original article, maybe not all of it, but it should contain the important information of what is in the article. And then there are some other things, like it should also be coherent, but I think that's sort of implicit in this information objective. What you want to do is, if someone reads this piece of text, they should get all the information that was in the big text. Or not all, but most, or the important information. Humans are quite okay at this, but it's not like we can really formulate exactly what we want, right? It's not like we can give a classification label and then tell the machine exactly, look, this class is correct and these other classes are wrong. Now, what people have been doing is they've built data sets where you'd have, for one particular document, you'd give it to, let's say, 3 different humans, and the 3 different humans would produce 3 different summaries, because different humans do it differently, right? So you'd provide 3 different summaries, and then you let your machine learning model produce some summary, and then your evaluation metric would be a metric that takes this piece of text and compares it to those pieces of text. And one of these methods here is called Rouge. So Rouge is a metric that looks at n-gram overlaps. So I have the Wikipedia page pulled up here, and you can see it consists of a bunch of sub-metrics, but there is a way to mix them. But in their essence, they basically look at overlaps of overlap of n-grams. So you can look unigrams or bigrams, you can look longest common subsequence and so on. Basically, you sort of try to compare the words, the text specifically in here, to the texts in the human summaries. And given the rich nature of language, that's not really a good approach, but it's the best one we have. Like we don't have a better metric to tell the machine what's right or wrong. And it goes actually further. So this Rouge as an evaluation metric, it's fairly bad. As we will see, they have a graph somewhere, and I might just draw the graph in that if this here is kind of the complexity of the information, and this here is how good the summary really is as rated by humans. So this paper plays a lot of emphasis on going to actual humans and asking them how good is a summary. If you employ Rouge, then at the beginning you increase the quality. So for easy text, for easy information, and for really bad models, the Rouge metric makes sense, because generally if you have a very crappy model and one that just outputs the same kind of text as the humans do, then that one's going to fare better. But then at some point it wanes off, and at some level of complexity, coherence, and so on, the Rouge metric is just not good enough anymore to differentiate good from bad summaries, or let's say to differentiate excellent from good but not excellent summaries. Let's phrase it like this. It's good at differentiating bad from good summaries, but not good from excellent. Okay, so that's one thing, that's evaluation. But Rouge, this overlap of n-grams, you can imagine that this is not differentiable. So the second problem is, how do we even train this thing, right? So this is eval, Rouge eval. But in training, you do something even less, let's say, something even that makes even less sense from just a principled point approach. What you want to do is you want to simply make the machine output these texts, right? So you simply say, these texts are correct. Now, please output those. It's kind of like a variational autoencoder that you want it to output a very specific picture, but you've given it that picture as an input. You can kind of imagine it like this. You say, this is the input, and this is the output I want you to produce. And now that I can actually backpropagate. I can backpropagate the production of this exact text from this input, right? So their model here is going to be some sort of a GPT-3 style model. It's not as big as GPT-3. Their biggest model, I think, is 7 billion parameters, whereas GPT-3 has, what, 175 billion parameters or something like this. So the model is going to work as follows. You take this text here, you just unroll it, I think some like this, so that it's just one string, and then you let the model produce. So here's the model is on top of this, and you simply always produce the next character or word piece right here, and then you produce the next, and you produce the next until you've output this thing here, and this thing here is going to be the summary. Okay, and that's a thing you can backpropagate through with simply language model learning. I'm ragging a bit too much because, of course, many things are trained like this in language learning, like translation is learned like this, just the simple generative language models are learned like this. So it's not that terrible, but you can see that evaluating with Rouge while training with this, both are not particularly suited to what we want. What we want actually is that humans would rate these summaries well. Okay. But we can't do that, and that's the problem that this paper solves. So here they show their final results already. So down here you have model size, but we don't worry about that right now, that because there's also a question of scale in here and so on. If they use a language model that was just pre-trained on language, so no explicit training for summarization. We've already seen in the GPT-2 and GPT-3 paper that if I take a piece of text and and I append the string TLDR, right? Too long didn't read, which in forum posts most often people put this and then they put a summary. Okay, so this prompts the model to produce a summary. If this seems mysterious to you, I've made videos on GPT-2 and GPT-3 explaining how this works. So a model that had just been trained on language modeling will actually be able to do summarization to a certain degree. As you can see right here, it's still below the quality of reference summaries. So this axis is really what humans, wow, that body attachment to the legs, is really what humans think of these summaries. So the way they evaluate it is they present a human with two different summaries. They ask them, which one do you prefer? Of course, if you give them human summaries, so one of them is always a human summary, but if you give them two human summaries, it's of course random which one they prefer, and therefore that's the 0.5 point. So if you give them one summary from this pre-trained model and one human summary, you can see that the pre-trained summary loses most of the time, loses like 70 to 80% of the time against the human reference summary. Then the second step is to take this model and produce what they called a supervised baseline. So that's what we've discussed just now when we said, how do we even train this? So we take a model that takes a database, a data set. Some reviewers are just calling datasets databases, and it freaks me out, and I've taken it over. I've seen it so many times now. There must be parts of the world where datasets are called databases. So in this, you have samples of text and corresponding summary. So you call this your X and you call this your Y, and you simply train a model to take in the X and predict the Y. Now, instead of a class label, it's simply a string, a piece of output string. You can do this with a language model, like a generative language model. That's the supervised baseline. So if they do that, they get closer, as you can see right here. So there is quite a bit of distance between this pre-trained model and the supervised baseline that starts from the pre-trained model but actually trains the model to do summarization. But you're still not at the level of these reference summaries. And then they have this mysterious human feedback model that now all of a sudden actually gets better than the reference summaries. It actually outperforms them. And we're going to look at how this comes about. So first of all, their contributions, as they stated, they say, we show that training with human feedback significantly outperforms very strong baselines on English summarization. Okay. We show human feedback models generalize much better to new domains than supervised models. Okay. And we conduct extensive empirical analyses of our policy and reward model. All right. So if you see the words policy and reward model, that already means that reinforcement learning is going to play some role here. And here's how it works. So this all already starts from the supervised model. So imagine what you've done so far. You have this pre-trained model. You've taken it, you've generated a supervised model for it. So the supervised model is explicitly trained to do summarization, but just on a data set. And now you want to incorporate human feedback, okay? So the way you incorporate human feedback is as follows. First, you collect the human feedback. And the human feedback here, you could do various things. So you could let the humans kind of score summaries. But what you want to do in this case is you always want to present the human with two different summaries and ask them which one do they prefer. Okay, that's going to be, our humans are going to be just doing this thing for now. They are going to look at two summaries and the corresponding piece of text. That's important. And they're going to decide which summary is better. And better in a human sense, better, right? So they work closely together with the researchers right here. And that's, I think, an advantage if you're OpenAI and have lots of funding and so on. It appears they've paid these humans quite well, and they've worked with them quite closely in order to ensure the high quality of their feedback. So the humans will always say, which of these two summaries is better? Okay. Now, what you could imagine is you could simply train a model using that, right? So the model produces this, and maybe one of the human summaries in the data set is that, and then the human decides is it better or worse, and then a model somehow optimizes this. This is not exactly what they do, because that would require too many humans. If you know these language models, they take a lot of data. So even though OpenAI has lots of budget, it's not really feasible for them to train these big language models, and every single training step for every single sample go and ask a human, what do you think? So they have to come up with some sort of different way to do this. So what they do is this entire thing right here, this entire thing right here will now be a data set, okay? It will be a new data set. So they take this supervised model and they produce a whole bunch of these summaries, and they always ask the humans which one's better. So this will be a data set, and the sample from this data set will consist of a big text, two summaries of that text, and it doesn't really matter how they're generated, just two summaries, and a label. And the label is either this one's better or this one's better. Okay, so this here is going to be now our X, and this one is going to be our Y of that data set. And to this data set, we now fit a model. So we fit a model to simulate the human. Okay, the model learns from the human. In reinforcement learning, this is very related to imitation learning, reward model learning. There are a bunch of names for it. In this case, they say we train a reward model. It's actually not exactly, sorry, it's not exactly imitation learning, because there you'd have actually samples of the policy and so on. So let's stick with reward model learning so that I'm correct. The exact way you do this is you don't actually fit the X to the Y right here, but what they train is this reward model right here. So this thing takes in, as you can see, a piece of text and one summary, and it predicts a number. And the number is supposed to say, how good is that thing? How good is that summary for that given document? And the humans never said that, right? So we can't directly use this as a label right here. We cannot, because we don't have this information. We just have the information whether it's better or worse than some other thing. So what we're going to do is we're going to take the same article and a different summary of the of that post. So one post with two summaries judged by a human are fed to the reward model. So this is fed to the same reward model. The same model gives the output for that one, and then we train. Our loss is going to consist which one's better. So the loss is pretty simple right here. You simply subtract them from each other. This is a sigmoid nonlinearity, and the log, because the loss is in log space. But the sigmoid right here, ultimately what that does is if, so here's 0, if post J is better than post K, this is going to be a positive number, right? So the sigmoid will map this to a 1 over here. If post K is better than post J, the sigmoid will map it to a 0 right here. And if they get close to 0, then something like this, right? So in this case here, post J is better, and in this case here, post K is better. So that seems like a sensible loss that you can regress on. So now you map these rewards to a 0 or a 1, and that's exactly what your label is. Your label is either a 0 if this post is better, or a 1 if this post is better. So now you have a data set, and you have a model that you can train, namely this model right here. So you're going to train this reward model on this data set. And you can iterate this at the end. Even though we aren't at the end yet, you can go back and do it all over again if you want. And I think they do. They iterate this, improving their summaries, asking the humans again, training a reward model. And then the last part is that you actually, now you have a reward model, right? Remember we said it was too expensive for humans to always go ask the human, which one do you prefer? Well, now we have a model that can substitute the human. So what we can do is we can simply use reinforcement learning to train the summarization model to maximize the reward. Okay, so now we give the model, this model right here, we give a piece of text and it produces a summary. Remember these models are exactly that. These models right here are exactly these models. Okay. In fact, we start from the supervised baseline. We plug this in here. That's the model that actually produces the summary. And we are going to fine-tune that using reinforcement learning. Now, PPO, proximal policy optimization, is a pretty simple but very effective reinforcement learning technique. So what you need is simply need an input, this your X, then you need an action. This is going to be our action. This is going to be our output of the model. And then you need a reward. So for the reward, you take this model right here. And this, at this point, this is fixed. So you learned your reward model, now this is fixed. Now you have a model that for each summary can give you how good that summary is. right? This reward. And you can use that to do reinforcement learning. So the reinforcement learning simply tries to generate a summary that makes the reward model as happy as possible. Right? And the reward model is learned from the humans. So you can see that at the end, through the proxy of the reward model, we are directly training for human enjoyment. So we are not training log likelihood like we did initially in the supervised baseline. We are not training for Rouge, which we could do with reinforcement learning, but Rouge itself is a pretty bad metric. We are actually training directly for what humans say they prefer, at least as far as the reward model can approximate the human preferences. So you can see that this is potentially a good approach. Now, this was also kind of, if you read this stuff in, let's say, on Twitter or elsewhere, people are, I think, very joyous that, wow, so we are aligning models with human interest, we are aligning them with human preferences and so on, human in the loop, yeah. It's still difficult. I think this is slightly overhyped in that direction, like the direction of where we go, say, wow, these are such good things. Because, so first of all, this costs a lot of money. Like, you need to work closely together with these humans, right? And I don't know where they say it, but they actually did not compare to a model that collected. So if you do this supervised thing right here, you have your data set, right, of text and multiple reference summaries. Well, okay. No one knows what happens if you invest as much time, money, and effort into collecting a bigger data set of simple reference summaries and then training a supervised model on that. Nobody knows, okay? So, and they say this, they admit this in this paper. They say, we did not, it's too expensive to also just do the control of what would happen then. But chances are that models are going to improve significantly as well if you simply provide a bigger data set of these. Okay, so it's questionable whether or not this modeling of the reward here is really the deal breaker, or simply the fact that they have collected much more and much higher quality data to train on, and then the reward model is simply the proxy for that data. So that's the first kind of dent here that's not really clear. Now, don't get me wrong, this paper is pretty awesome, especially because they evaluate all the summaries using humans as well, and that costs a lot too. So regardless of training, even evaluating these summaries in terms of not Rouge but actual human feedback is very expensive, and they do this as well. And this is of course pretty awesome and gives you the most accurate signal. That alone is commendable, but I don't believe yet that this reward modeling is the thing that made the improvement here in their training procedure. The second thing is they do the following. Their reward for the PPO algorithm isn't actually just the reward from the reward model, as you can see here, but it has this KL term in here. So what does this KL term do? So here is this is the supervised baseline. The supervised baseline is simply a model that, as we said, was trained to input a post and output one of the summaries that the humans provided. This thing right here is the reinforcement learned baseline. So this is the thing that's actively changing during PPO. Okay, so, and you constrain this to stay close to the supervised baseline. So you don't want your reinforcement learned model to go far away from the supervised baseline model. So in terms of the reward, your reward is going to be the reward that you get from the reward model that is trying to predict how good humans like the particular thing, minus a penalty, so minus a penalty term if you are too far away from the supervised baseline. And this should remind you of something. So you're kind of trying to optimize especially if you look at the diagram of the model, right? Because you have piece of text, right? And then you have your model right here that you train. And then you have the output summary, okay? And then you have the reward model. And you have the reward as an output that you're trying to make as big as possible. Now, what does that remind you of? If you look at this model right here, you're trying to optimize its input, right? This is the input to that model in order to make its output a certain way, all the while making the input be not too far away from some reference input. This should remind you of adversarial examples, all right? Because what's happening right here is exactly we are trying to find an adversarial example to the reward model, okay? It's not adversarial in the sense that it tries to maximize its loss or something like this, but it is trying to maximize its output, its reward, and it's trying to manipulate the input to the reward model such that the reward is as high as possible. And what do we know about adversarial examples? Is that they aren't really part of the normal data spectrum, if you will. So, and we're going to see this, and they have this problem as well. So if they constrain, there is a parameter there where you can trade off how close you want to stay. So how much freedom do you give the reinforcement learning to go away from the supervised baseline? And you can clearly see that here is the fraction preferred by humans, and here is this KL. If you optimize with reinforcement learning and you let the reinforcement learning, you give it some room. The more to the right here, the more freedom the reinforcement learning model has. You can see that it goes up and up, but after a certain while, it is flat and actually goes down again. So if you purely reinforcement learn, what you really find are adversarial examples to the reward model that have nothing to do with the humans anymore, because it's really just an adversarial example. And to demonstrate this, they have this nice piece in the appendix where they give samples from these over-optimized policies. So policies that are just over-optimized to this reward model. So here, and we don't see the piece of text, which I find is also interesting because here we are just, the reader of the paper is just tasked with judging without finding the piece of text, without reading the piece of text, which is interesting that humans can actually do this. Makes you kind of think of how it all works. But so here, the reference summary that a human wrote was, I'm 28, male, live in San Jose. I would like to learn how to do gymnastics, okay? 20-year-old dude stubbornly postpones start pursuing gymnastics hobby, citing logistics reason despite obvious interest, question mark. Negatively affecting long-term fitness progress personally. It just seems like these websites that people made to rank high on Google because it has all the terms that make Google happy, which, I mean, something like this is exactly happening here, right? You're just trying to fit everything in there to make the reward model happy. The reward model was only ever trained on, let's say, coherent summaries, textual summaries. So if you go away from this data manifold, you can find things that score high, but that a human wouldn't rate high. That's simply because the reward model isn't all knowing. It's simply a neural network, and they are susceptible to adversarial examples. Left password saved on work computer replacement, spends every hour of the day watching Netflix. Employee stubbornly postpone his replacement. So despite trying reasonable question mark, negatively affecting productivity. You can already see that there is some sort of a pattern here negatively affecting. So this policy simply finds like this structure of text stubbornly postponees that seems to make the reward model very, very, very happy, but it really goes away from the text right here. It's pretty cool actually, because you see my fridge, and that it kind of copies over the words in what it already knows. It makes sense. And I think this ties a lot into what I've been saying about how GPT-3 works, because this is kind of a really dumbed down version of GPT-3. It's actually the same architecture, and you can pretty clearly see that what it does is interpolate different things. So in this case, it interpolates what it knows makes the reward model happy, which seems to be these phrases right here, and it interpolates the kind of important words from the text on the left a little bit. So it sort of understands what makes the reward model happy, and thereby you can already see how a reward model like this may work, in that it will sort of judge whether or not some of the words are present right here. And that's 100% due to the reward model, I think, not being trained on, sentences like what we've just seen, because even the supervised baseline, the summaries are going to be pretty okay, and especially the human reference summaries are going to be pretty okay. For the most part, they're going to already be coherent, they're going to be linguistically correct, grammatically correct, and so on. So it just never seen that space of data, right? If we scroll back through this giant mess right here, this is already, it's already the paper basically. So after implementing this particular reward, you can see that they now have a handle right here on how much the RL is supposed to go away from the supervised baseline. If they simply constrain this to some reasonable degree, then the reinforcement learning seems to improve the summaries. Okay. So the results here are, you've already seen, I think, the main results in that they are pretty good. Especially, you can see this they also ask the humans to rate summaries in different different areas. And you can see that the reference summaries are always, or most of the time, better than the supervised baseline and also the pre-trained only models, yet the human feedback models, they outperform the reference summaries, which is, it's pretty cool, because you'd think that humans would be sort of very good at this stuff, but the human feedback, you can think of it as kind of emulating an ensemble of humans. So the reference summary is just a single human writing a summary, and the human feedback is optimizing a model that's kind of tries to integrate all of the human summaries that exist from a particular post. Of course, it would be interesting to see of how diverse the summaries would be. I believe they have some experiment where they sample with different temperatures, but still, maybe there's a trade-off with diversity here, that it always goes for the best one. And they do a lot of experiments. I don't want to actually get into, they also transfer this to this news data set. So they simply trained on Reddit, but then transfer it to the news data set, which it works pretty well, as you can see right here. So it works almost as well as a supervised baseline that was directly trained on that data set. And that's fairly cool. So I definitely think that there is a value, and the criticism of Rouge definitely is warranted. Also the question of how we train with things such as summary, where we can't even really formulate what we want. Like, there's a trade-off with length as well. The incorporation of human feedback is very valuable. So the last part they do is understanding the reward model. They ask themselves, what what does the reward model actually learn? And this is where I'm a little bit disappointed. And here, though, this is very valuable, right? The fact that they show that if you let it go too far, if you optimize only for the reward model, you fail. They also do investigations into model size and how much data you need and so on. They change a little bit the things, which this is pretty cool, where they say we construct an additional validation set by having labelers make minimal edits to summaries to improve them. Our reward models prefer the edited summaries almost as often as a separate set of human evaluators. So the reward models can sort of spot when summaries improve and so on. They do a lot of validating that the reward models are actually in line with human preferences. However, as we see, if you directly optimize for the reward model, if you are allowed to go away from the data manifold of valid summaries, then anything can happen. And that's the danger with incorporating reinforcement learning right here. You can also see they're clearly better than humans. So here are these curves that I draw at the beginning for these reward models, whereas the rouge, as you can see, it just flattens out after a certain complexity. What they don't investigate, what would be really interesting, is just something that I would find interesting is how much the reward model actually depends on the input post. Because it seems like you could, trade off information in the input post and coherence and so on by looking at what happens if you actually change the input post. Does it matter a lot? How much does it matter? And so on. So it would be fairly cool to look at, especially given that we humans can apparently look at these summaries and judge them fairly well by just looking at the summaries. Of course, we have no clue what the article said. Yeah. All right. So here they discuss some limitations. And they're, of course, very, very open about the limitations right here. It's extremely skill intensive, time consuming to produce good ones, and expensive. So yeah. The last thing here is the broader impact statement, and they, of course, go through the full trifecta of broader impact statements, which, again, to repeat, so you have to do this. So here is you, and you take your hand, and you go like the Catholics go. You touch here, you touch here, you touch here, or the shoulders here and here, and you say the magic words. The magic words are technology good, technology bad, technology biased. Okay, so what you want to do is, it's technology, which is a metaphor that broader impact statements, they never actually deal with the exact method in the paper. They always go like up one layer or two. And of course, the extreme is technology. So you don't want to talk bad about your technique, because my God, your technique isn't bad, is it? So you just go up and you say, whatever, language models can be bad or good, or machine learning can be bad or good, or technology. So first you say it's good, right? So many potential positive effects of aligning machine learning algorithms with the designer's preferences. And again, I think this is a bit overhyped, this aligning, because we clearly see that the way they do it, if you align too much, it is misaligned again, ironically. Then bad. So unfortunately, our techniques also enable malicious actors to more easily train models that cause societal harm. Yes, that's the technology bad part. And you can see, for instance, one could use human feedback to fine-tune a language model to be more persuasive and manipulate humans' beliefs. So we're talking about language models. We're not talking about summarization here in this particular case. We're talking about language models. So that's the technology part. And then technology bias, so you can pretty clearly predict that there's going to be a part that is something like, there you go. However, since the dataset consists of user-submitted posts with minimal moderation, they often contain content if offensive, reflect harmful societal biases. This means our models can generate biases or offensive summaries as they have been trained to summarize such content. At least this is actually about, summarization. At least this is actually about the model in question right here. So props to that. But if you ever write a broader impact statement, the holy trifecta of broader impact statement must apply, and you're good. All right, that was my thoughts for this paper, a bit of rambling. Look at the paper, look at the appendix, look at the code that they've released. I believe they've even released this small model. They have a 1 billion parameter model. I don't want to promise too much, but yeah, they have a lot of appendix, a lot of experiments right there. And check out OpenAI. With that, that was it from me. Bye-bye.